So today we want to kind of finish up talking about the nonlinear factors of polynomials, and it's going to piggyback off what we talked about yesterday, and we're going to be working on the conjugate theorem, very similar to the complex conjugate theorem that we worked on yesterday. So remember, complex or imaginary roots have to come in pairs, and that pair is called a conjugate pair. So we talked about that if 5i was a root, then negative 5i had to be a root. Well, the same is also true for irrational roots. Now remember, irrational numbers are real numbers. They're real numbers. They're not imaginary. They don't have I, but they are those numbers that have the square roots that don't have a nice, even, clear square root. We don't know what it is. It's that decimal that never stops and never repeats. Square root of 2, square root of 7, all of those types of numbers. So irrational roots also have to come in pairs. It all goes back to that square root. Remember, when we're using a square root to help solve something, we always have to put the plus or minus in front of it. And because of that plus or minus, that means that that square root answer, that square root, is always going to come in a plus minus pair. Well, they are also called conjugates. It's all about that plus minus. Things with those plus minus that comes in those plus minus pairs are conjugate pairs. So just like with I yesterday, if the square root of 5 is a root, it's not going to be an answer. It's not going to be a solution unless negative square root of 5 is a root. And negative square root of 3 is not going to be a root unless square root of 3 is a root, because they would be plus or minus. Just like yesterday, we also know irrational numbers sometimes have a rational part to them. Sometimes it's 3 plus the square root of 2, but that plus wouldn't have just been a plus. It's in front of a square root. It would have been a plus or minus. So that means 3 minus square root of 2 has to be a root. And negative 7 minus square root of 5, this wouldn't just be a minus. It would have been a plus or minus. So that means negative 7 plus the square root of 5 would have also been a root. So anything with the square root, that includes I and irrational numbers, that square root has to have plus or minus. It has to be a pair, and it's always going to be that way. So just like with the imaginary roots, our irrational roots come from a quadratic factor instead of a linear factor. So all our polynomials can be broken down into linear or quadratic factors. And that's one of the reasons that we study linear and quadratic polynomials on their own before you ever get to other polynomials, is because they're the building blocks of all polynomials. So if you want to get to something to the third power, something to the seventh power, it's by taking linear and quadratic polynomials and multiplying them together and getting a larger polynomial. So they're the building blocks. Other important things to remember, we know that roots and solutions and factors and x-intercepts, those all fall into the same, using the same numbers. Remember, x-intercepts exist for irrational numbers. You would be able to see on the graph where 3 plus the square root of 2 crosses the x-axis. But imaginary roots do not show up on the graph because where it crosses we don't have the imaginary numbers on the graph. So how do you write an equation if you are given irrational roots? So let's say negative 5 and negative square root of 3 are roots. So if we know that these are the roots, again, we can write them as factors. So I'm looking at negative 5, so that must have been x plus 5 as its factor. But this is negative square root of 3. I know it wouldn't have just been negative square root of 3. It must have been plus or minus the square root of 3, because that square root would have had a plus or minus in front of it. So it is both of them. And just like yesterday, we want to remember that x equals plus or minus the square root of 3. And so I don't have anything being added or subtracted from it. The irrational, just like yesterday, we had to get the imaginary by itself. We have to get that irrational by itself. So there's nothing being added or subtracted to it. So I just want to get rid of the square root, and to get rid of a square root, we square it. So now I have x squared is equal to, and my square root cancel out, and it's just going to be 3. To get it equal to 0, I'm going to subtract the 3 from both sides, and so this is going to be x squared minus 3 is the quadratic factor for that root. So remember, irrational and imaginary roots have to have a quadratic factor, not a linear factor. So I'm going to have x plus 5 times x squared minus 3. And then just like yesterday, if we're actually looking for writing the equation, this would be the factored form of the equation. If we needed standard form, we would need to multiply that out. And that's just something where you want to pay attention to the directions. Technically, this is the equation. I could leave it like this. If your directions say write an equation in standard form, well, then you do have to multiply it out. So this again goes back to read all the words. Make sure you're reading the directions. So I'm going to double distribute and figure out what this is equal to. So I'm going to get x cubed plus 5x squared minus 3x and minus 15. So this would be the equation that would have roots that are negative 5 and plus or minus the square root of 3. So how do you write an equation if you're given irrational roots? Let's do some different roots. So one root is 1/2, and one root is 5 plus 2 on the square root of 7. All right, so again, yesterday we talked about if x is equal to 1/2, I don't want it to be a fraction. So I'm going to multiply both sides by 2. So I get 2x is equal to 1. And then when I subtract that 1 from both sides, I get 2x minus 1 is the original factor that would have given me a root of 1/2. So it's a rational number. It has a linear root. This has a square root in it. It's an irrational number. This isn't just plus 2 on the square root of 7. It's plus or minus 2 on the square root of 7. We don't get a square root without a plus or minus in front of it. So it is a pair. It has to be both of them. So x is equal to 5 plus or minus 2 on the square root of 7. So again, I can't square this side while it still has the 2. It's a binomial. So I want to subtract the 5 and move it over with the x. So now I have x minus 5 equals 2 square roots of 7. We know it's plus or minus, but we also know we're going to square it and get rid of the sign anyway. So I just stopped writing it. Now I have the irrational number by itself, and I just want to square both sides. So just like yesterday, when you do have a binomial over here with the x, you do have to make sure you double distribute, FOIL, area model, box method, whatever you want to call it. I need to make sure that I'm doing x minus 5 times x minus 5. So that's going to be x squared minus 10x plus 25. So over on this side, we have x squared minus 10x plus 25. And then on this side, we do want to remember that when you have two things that are being multiplied, not added or subtracted, multiplied, and you square them or cube them, you do have to take both of them to that power. So 2 squared is 4. And the square root of 7 squared, the square and the square root will cancel, and it will just be 7. So over here, we actually have 4 times 7, which should be 28. And now we're almost done. We've almost got it equal to 0. We got rid of the square root. And when I subtract 28 from both sides, I'm going to get that this quadratic factor is x squared minus 10x minus 3. So again, if I was just writing an equation, this is an equation, it's just in factored form. But if the directions say to put it in standard form, then I do need to multiply it out. This is a lovely trinomial times a binomial. So I do like to use my area model to help me multiply that out so I don't leave something out by accident. I'm going to get 2x cubed negative 20x squared negative 6x negative x squared. Negative times negative will be a positive 10x. And a negative times a negative will be a positive 3. So my equation that has roots of 1/2 and 5 plus or minus 2 square roots of 7 is going to be 2x cubed. Then we have negative 20 and negative 1, so negative 21x squared. Positive 10 and negative 6 is going to be positive 4x, and then 3.